Hey guys, welcome back to the channel. Today we're going to be solving LeetCode 231, okay, power of 2. Feel free to pause the video to read through what the problem is asking for. However, examples are really descriptive. Okay, so given a number n, we want to return true if the number is a power of 2. In this case, 1. If you raise 2 to the power of 0, you get 1. So yes, 1 is a valid power of 2. Okay, given 16, okay, if you raise 2 to the power of 4, you get 16. So we want to return true if it's a valid power of 2, but false if it's not. For instance, in this case, 3. No matter what you raise 2 to the power of, it's never going to give you 3. So as always, there's two ways to solve this problem. There's multiple ways to solve this problem, but I want to do it in two ways. The first way is to, okay, we know first of all that no negative number is going to be a power of 2. Okay, no negative number, because you can't get a negative number by raising 2 to whatever. Okay, you can get fractions, but no negative number. So an if check for that. If n is less than equal to 0, okay, just saying, if n is 0 or negative, okay, it can't be a power of 2. So just go ahead and return false. Okay, else if, okay, n equal 1, like in the example we were given. If n is 1, return true, because obviously 2 to the power of 0 is 1. Okay, else, so this is the meat and potatoes of our code. Okay, we want a while loop that keeps going while n, the number we're given, is greater than 1. Okay, as long as it's greater than 1, we want to keep dividing by 2 and see if it's a power of 2. So if n modulus 2, okay, so we're checking if it's an even number. If n modulus 2 is not equal to 0, okay, it has to be equal to 0 when you divide that number by 2. If it's not equal to 0, return false. Okay, once you do this, we want to reduce n, so we just say n is equal to n divided by 2. So we dividing by 2, so we get a new n. And then if we completely go through this while loop and we never return false till n becomes 1, we just want to return true, because he's obviously a power of 2. So let's go ahead and run this code first. Okay, accept that. Let's go ahead and submit it and see what's going on. Okay, bam, faster than 69 percentile. Okay, 69 and 97. So let's get a snapshot, okay, of this, just to keep track of this, because we're going to solve this a second way and we want to compare and see. Okay, so the second way, which I believe is a lot simpler, okay, is just to define an index, an I. In this case, we initialize him to 1, and then we say wow. So essentially what we're doing here, we're starting from 1 and counting all the way up till we get to n. While I is less than n, okay, we want to start from 1 and count up to n. Okay, I is equal to I multiplied by 2. Okay, so we're just multiplying I by 2 every time. So 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. But just keep going till we get up to n. And if we get to n, if we get to exactly n, we want to return true. So essentially it's shorthand. So we can do it like this. If I equal n, once we're done with the while loop, if I equal n, we return true. Else, we return. Okay, this is the right way to do it, but it's a cleaner way to do it. And the cleaner way is just to say, okay, this will work, but the cleaner way to do it is just to say return I equal n. So if I is really equal to n, it's going to return true. If not, it's going to return false. So let's go ahead and submit this and compare it to the previous one. Okay, so this solution is, in terms of time, it's much faster, but in terms of space, it's not as good. So that's it for the video, guys. I hope this was really helpful in showing you guys different ways to solve this problem, and I'll see you in the next one.